What's up guys, welcome to this video. I'll be going over the June 2022 paper 2H. Okay, so let's begin with question 1. It says simplify x cubed and that's powered to 5. So what do we do when we have a power to a power? We multiply. So it's going to be 3 times by 5. So that gives us x to the power of 15. Next, expand and simplify. So we expand the first bracket, so we get 4x, 4 times 3 is 12, and then we do the same for the second one. So 7 times 4, that's 28. 7 times minus 2, which is minus 14x. And then we collect the like terms. So we've got the x here, and minus 14, 12, and the 28. So 4 minus 14x is minus 10x, and 12 plus 28 is 40. You could write this, or you may decide you want to put the positive first, so you get 40 minus 10x. Next, factorize fully 15x cubed plus 3x squared y. So we're going to have a single bracket, and this is something that you need to get used to when you have a single bracket, when you have a double bracket. You normally have a double bracket when you have a quadratic in the form ax squared plus bx plus c, something in that form. And as you can see here, we don't have that, so we're going to have single brackets. So what's the highest common number that goes into 15 and 3? It's 3. So we can take a 3 out. Next, if you look at the x's, you've got x cubed here, we've got x squared here. So the minimum that we can take out is x squared. As for the y's, this has a y, but this doesn't, so we can't take the y out. Okay. So now we need to think about what goes in here. When we multiply, we will get this. So 3 times what? 3 times 5. So 5 goes here. That gives us 15. Now we want an x cubed, so we're going to have to put another x in here. When we multiply the x and the x, we get that x cubed. What goes next? Plus, and we've got the 3 outside already, so we don't need a 3 inside. We've got the x squared outside already. We don't need an x inside, but we do need a y. And that's our answer. Question 2. Describe fully the single transformation that maps shape S onto shape T. So how did this go to that? So clearly you can see the orientation is the same. It's the same way up. So it must have gone up by something and then across. Or you could say goes across by something and then up. Usually what I do is I just look at a point here and then I look at a corresponding point over there and I think about how that got there. So 1, 2, 3, 4, 5. It went 5 steps back. So it went 5 steps back. I'm going to be writing it in my vector form. So 5 steps back will be minus 5. Okay, because it's going towards a negative. And then after 5 steps back, it went up how many? So it went up from here, 1, 2, 3, 4, 5, 6. So that point ended up there. So 6 up, so 6 goes in there. So what will I say in here? I will say it's a translation, because that's the name of that transformation. Translation by minus 5, 6. You could say translation by going left 5 and up 6. That should also get you the marks. Question 3. The length of a football pitch is 90 meters, correct to the nearest meter. Complete the error interval for the length of the football pitch. So it's been rounded to the nearest meter. So the lower bound is going to be 89.5 and the upper bound is going to be 90.5. Question number 4. Festival A will be in a rectangular field with an area of 80,000 meters squared. The greatest number of people allowed to attend Festival A is 425. Festival B will be in a rectangular field 700 meters by 2,000 meters. The greatest number of people allowed to attend Festival B is 6,750. The area per person allowed for Festival B is greater than the area per person allowed for Festival A. How much greater? Give your answer correct to the nearest whole number. Right, so where do we begin? Let's take that first sentence up there, okay, and start to put this into words. This is known as scaffolding. So I'm scaffolding the problem. I'm building up, all right? So if I draw a rectangle, and images help as well. So if you can draw images as much as you can for these types of questions, it's great, okay? So I'm told that it has an area of 80,000 meters squared, okay? And 425 people can fit in there. As for festival B, I'm going to do the same thing, draw a rectangle, and I'm going to do the same thing for festival B. And for that one, I've been given the lengths, okay, right here. So 700 meters by 2000. So let's call this 2000 meters and this one 700 meters. I can quickly work that out, the area of that, by doing 2000 times by 700, and that is 1,400,000 meter squared. Okay, so that's that. And what am I told about this? That 6,750 people can fit in there. So 6,750 people can fit into that one. Now, if you go into the third sentence right here, it says the area per person allowed for B is greater than the area per person allowed for A. How much greater? So let's work out for each of these the area per person. So it's the area per person. That would mean, if you look at the first one, A, it would be 80,000 meters squared divided by the number of people. And that gives 188.24 meters squared per person. Okay, I'm going to do the same thing for the other one, for B. So that's going to be 1,400,000 divided by 6,750. And that gives 207.41 meters squared per person. So now the question says, how much greater is the per person allowed for B greater than the per person allowed for A? So I'm going to be taking them away. So I'm going to do 207.41 meters squared, take away 188.24 meters squared, and that gives me 19.17 meters squared. And to the nearest whole number, because this is another thing that you've got to be careful of here, to the nearest whole number, that would be just 19. So that's your answer. The next part of this question, Callum says 300 centimeters squared is the same as 3 meters squared. Because there are 100 centimeters in 1 meters, so you divide by 100. Callum's method is wrong. Explain why. Well, forget about what Callum says. Let's just focus on 1 meter. In 1 meter, how many centimeters are there? There's 100 centimeters. Okay, then in 1 meter squared, what's that going to look like? Well, 1 meter squared isn't the same as 100 centimeters squared. All right, this is the mistake that he made. You're looking at area here, okay? So if you have the area of something, let's say 100 centimeters and 100 centimeters, that's the same as 1 meter and 1 meter, right? So how do you find the area of this square? Well, the area of this square would be 1 times 1. Well, 1 times 1 is 1 meter squared, no problem. But if you use the centimeters to do that, that's not going to be 1 times 1. It's going to be 100 times 100, right? And 100 times 100 gives you 10,000 centimeters squared. So 1 meter squared is actually 10,000 centimeters squared. So therefore, if you want to know, let's take this one. Let's take the 3 meters. If you want 3 meters squared, 3 meters squared is not going to be 300 centimeters. No, you need to multiply this by 10,000. Okay, so that will give you 30,000 centimeter squared. So 3 meters squared is equal to 30,000 centimeter squared, not 300 centimeters squared. Okay, so question 5. The points L, M, and N are such that L, M, N is a straight line. The coordinates of L are such and such, M is such and such. Given that LM to MN is in the ratio 2 to 3, find the coordinates of N. So let's do a little picture or a diagram here that will help us. So let's start off with L. So let's say L is here. So L is 3, minus 3, 1. Okay, we're told that. And then let's say M is here, and M is 4, 9. And then N is somewhere up there. We don't know exactly what N is. So currently we don't know nothing about N. Okay, we just know there's an X and a Y. Now this is deemed to be a straight line. So if we draw a line through here, it's not very straight. I'm just going to manipulate that a little bit to make it look as though it's straight. There you go. We have a straight line now. Now what we are told is the distance between LM and MN is in the ratio 2 to 3. Okay, so what that means is if I were to draw a triangle underneath, that means from here to here, as we know currently, it's gone from -3 to 4 for the x. All right, so if it's gone from -3 to 4 on the x, that means it is a total of 7 units across. Likewise, we go from here up, so we go from a 1 down here to a 9 up there. Again, that's 8. So going up is 8. Now we are told that the ratio of L to M and M to N is in the ratio 2 to 3. All right, so that means this is 2 and this is 3. So 5 parts in total, right? Now, if we were to continue drawing another triangle like this, similarly, this length here is going to be 7 multiplied by the scale factor. Now you can do the scale factor in one of two ways. Okay, I will show you one way and then I'll show you the alternative as well. So whichever one your head agrees with more, that you can understand. So if I want to find this length here, so remember I left off on the 4 on the x. I want to know what the x here is. Okay, that's what I'm trying to do here. So I can use the following. I can say, well, from here to here we know is 7, and that is worth 2 parts. Okay, and from here to here is going to be an unknown, but we know that it's 3 out of those 2 parts. Okay, so that right there, I can do 7 times by 3 over 2, and that gives me 10.5. This means this length here is 10.5. So I can take the 4 and I can add the 10.5 to get the x here. Okay, so that would be, for the x, I could do 4 plus 10.5, and that gives me 14.5 for the x coordinate. So that's 14.5. Then I'll do the same thing for the y. Now for the y, I know that this is what needs to be found. I already know this is 8, so it's going to be 8 times 3 over 2. Just to remind you again, 3 parts, 2 parts. Okay, so 3 over 2, and that gives me 12. So therefore, I'm going to start off on the 9, because that's 9, remember, and add the 12. So that's 12, and that was 10.5. So I'm going to do 9 plus 12, and that gives me 21. So this right here is 21. The alternative method, and I'll do that right here, is we know that this is 7 and it's worth 2 parts, right? And we want to know all of that, which we know is 5 parts because 2 and the 3 here. Okay, so it's going to be 7 divided by 2 and then times by 5. And that gives us straight away an answer of 17.5. So from here to here is 17.5. So you do -3 plus 17.5. And that gives you 14.5 for the x. So do the same thing for the y. So we know the height here is 8. So it's going to be 8 divided by 2 times by 5. And that gives you 20. So therefore, you start with a 1 and you add 20 to get this. Okay, so 1 plus 20 is of course 21 as well. And that's how you end up with your full coordinates. So 14.5 and 21. Question 6. A new phone costs £679. The value of the phone decreases at a rate of 4% per year. Work out the value of the phone at the end of 3 years. So you could use the formula original amount times by the multiplier. We need to work out what the multiplier is first. So if it's a decrease of 4%, that's going to be a multiplier of 0.96. So original amount is £679 times by 0.96. Now that's going to be powered to 3 because at the end of 3 years we're looking for. Put that straight into your calculator and you get an answer of £600.74. Question 7. In Spain, Sam pays €27 for 18 litres of petrol. In Wales, Leo pays £40.80 for 8 gallons of the same type of petrol. And we're being given the conversion for euros to pounds and litres to gallons. Now, Sam thinks that petrol is cheaper in Spain than in Wales. Is he correct? Now, there's various ways that you can do this. I am going to make everything in liters and everything in pounds. All right. So let's start with Spain first. Right. So in Spain, we are told that you pay in 27 euros for 18 liters of petrol. So 27 euros equates to 18 liters of fuel. Now, I want to go from euros to pounds. So how do I do that? Well, I know that 1 euro is 0.85 pounds. So therefore, to go from euros to pounds, we divide by 0.85. So I'm going to divide this by 0.85. So 27 euros divided by 0.85 will give us the pounds, and that gives us 22.95. So this is how much you're paying for 18 liters in pounds. Let's look at Wales. So for Wales, we are told that Leo pays £40.80 for 8 gallons. So I've got this in pounds, that's good, but this is in gallons. I need that in liters so I can relate to this. So how do I make gallons become liters? So if you look at the conversion here, 4.5 liters is worth 1 gallon. So if I'm going from gallon to liters, I'm going to go this way, all right? So how does 1 become 4.5? You do times by 4.5. So 1 becomes 4.5 by multiplying by 4.5. So therefore, I'm going to multiply the gallons by 4.5. So that will tell me that £40.80, I don't need to do anything there. I'm just converting the gallons to liters. So 8 times 4.5, that gives me 36. So 36 liters. Now, let's have a look at these two statements. One there, one there. So in Spain, I'm paying £22.95 for 18 liters. In Wales, I'm paying £40.80 for 36 liters. Now, it's still not comparable yet, or not easily comparable. So what I want to do now is work out the price that you pay per liter. So this here is going to be for Spain, it's going to be £22.95p divided by 18. That gives me a value of £1.20. Well, let's just leave that in 3dp for now. Liters. Okay, that's how much you're paying per liter. In fact, I shouldn't write liters, just write liter. Next, this one, £40.80 divided by 36. And that gives us £1.13 per liter. So where are you paying less? Well, clearly you're paying less in Wales. So Wales is cheaper. Sam is therefore incorrect. Okay, question 8. Use your calculator to work out, and it's got a very complex calculation. Give your answer correct to 3 significant figures. So I'm going to show you how this is done by using a calculator. So as you can see, here's my calculator. So the first thing I'm going to do is press a fraction, then the cube root, which is only for the numerator, and then 1.57 to the power of 4. Press a cursor to the right, plus tan 60, close that bracket, go down 7.2 to the power, again fraction button, a half is the power, and that gives us 0.73933794027. Now I want to round this to 3 significant figures. So this is the first significant figure, this is the second one, and this is the third one. So as you can see, this number here is less than 5. So my answer is going to be 0.739 to 3 significant figures. Question 9. A box in the shape of a cuboid is placed on a horizontal floor. The box exerts a force of 80 newtons on the floor. The box exerts a pressure of 187.5 newtons on the floor. The face in contact with the floor is a rectangle of 1.2 meters and x meters width. Work out the value of x. So the area of this rectangle, 1.2 meters, and x is the width. So to calculate the area of this face is going to be 1.2 times by x, which is simplified as 1.2x. Now, if we take the formula that's given to us, the pressure formula, now the pressure is given to us as 187, so we can replace that with 187.5, and the force is 180. Now, what do we have for the area? Well, this is what we have for the area. So we can write in here 1.2x. Now we just need to solve that, and then we can find the value of x. So to solve that, we'll take this, multiply it over here, and that would be 1.2x times by 187.5, and that equals 180. And I'm not going to actually multiply this. What I'm going to do instead is I'm going to divide this side by 187.5 to get rid of this here, and that will divide over here. So I get 1.2x is equal to 180 over 187.5, and that gives me on that side 0.96. Finally, to find out what x is, I'm going to do 0.96 divided by 1.2, and x is equal to 0.8. So the answer for x is 0.8. Question 10, you've been given a box plot showing the information about the sales in an online store each month. Andrew says 3/4 of the given data lies between 160 and 350,000, because these are the values of the lower quartile and the upper quartile. 3/4, well, lower quartile and the upper quartile are this point here and that point there, which is indeed 160 and 350,000, but that does not represent 3/4. The interquartile range, which is what the upper quartile minus the lower quartile gives you, represents the 50% of the data, not 3/4 of the data. So that's why Andrew is wrong. Second part of this question, the table shows information about the sales in the shop each month. On the grid below, draw a box plot for this information. All right, so I like to draw my quartile, median, and upper quartile first to give me that box shape. So let's start with that. So if you look at these squares, from here to here is 100. So that means this is 50, and therefore each of these is 10. All right, so 80 here, 50, 60, 70, 80 right there. Okay, like that. That's 80. So that's my lower quartile done. Next, median is 170, so that's 150 right here. So 60, 70 right there. Okay, that's my median. I'm going to do the same height as the other one. There we go. That's that done. Upper quartile, 260. So 250 is here, so 260 is there. And I'm going to box that up right there. So that's the lower quartile, median, upper quartile done. Now the least value, 30. So 30, 20, 30 right there. And it's a smaller line that I draw. And I'm going to go up to it like that. So that's the least value done. The greatest value, 350. Again, a small one, 350. Go across. And that's done. And there's my box plot. Now the question goes on to a part C, which says to compare the distribution of the sales of the online store with the distribution of the sales of the shop. Okay, so I need to look at both of these box plots together. Now, what you can see is for 2 marks as well. So that's something to be noted of. So you need 2 different points. Okay, that's what you need to think about when you give these questions. So if we go out and look at both of the box plots, what do we see? Usually you want to talk about the median, the interquartile range, something like that. Okay, and you can see here. So let's start with the median. You can see for the online store, the median is 200, and for the shop, it was 170. We've told that here as well. So the shop has a smaller median. This means that you can say median of shop is less than online. And what does that mean? That means on average, the average person spent more online than in the shop. So let's see if we can find something for the interquartile range now. So what is the interquartile range? You can see this one, it goes from, what's that, 350 to 160. We can get that from there. And on this one, it's going to be from 260,000 to take away 80,000. Okay. So the interquartile range, the first one is 350 100,000 minus 160,000. That's for the online shop. And that is 190,000, the interquartile range. And for the shop, it is 260,000 minus 80,000. And that is 180,000. So this is the online, and this is your shop. What you could say here is that the IQR is larger online than shop. And that simply means that the shop sales were more consistent. You could also say that because it's smaller interquartile range, so it's more consistent. It shows consistency. Question 11. Kieran has 13 workers he can use for a job. He knows that 6 of the workers would take 14.5 days to complete this job. Show that Kieran has enough workers to finish this job in less than 7 days. How I like to show my students on how to start these questions is write down the facts. So what do we know? We know 6 workers take 14.5 days. So 6 workers take 14.5 days. Now, let's find out what 1 worker takes. So what does 1 worker take? We do divide by 6 here, but on the other side, because this is indirect proportion, okay? I'll explain what I mean by this. Because if you have 6 workers that take 14.5 days to do some work, and if you reduce the amount of workers, would you expect them to take 1 worker to take more time or less time than 14.5 days? Of course, more time. So we multiply, this is known as indirect proportion, and we multiply the opposite side. So if we do divide here, we multiply here, okay? And I have a video on direct and indirect proportion. You can go and check out if you need more help and support on this topic, all right? So we times by 6. So 14.5 times by 6 would mean that 1 worker takes 87 days to do that same job, whatever it is. Now, Kieran wants to know whether his 13 workers can finish the job in less than 7 days. Let's see. Let's go up to 13 workers then by multiplying this side by 13. So once again, what will we do on the other side? Will we multiply by 13 or divide by 13? Of course, we are going to divide by 13. Why? Because if you have 1 worker that takes 87 days to do a job and you've got more workers on it now, then this time should reduce. And to reduce that, you divide it by 13. So 87 divided by 13, that gives you something like 6.69 days. And that's enough for us to know that we can complete in less than 7 days. So less than 7 days with 13 workers. So yes, he can. Question 12. The equation of the line L1 is y is equal to 2x plus 3. The equation of the line L2 is 5y minus 10x plus 4. Show that these 2 lines are parallel. Right, parallel is when they have the same gradient. So what's the gradient of line L1? So L1's gradient is simply the value in front of the x, which is 2. So it's 2. And what's the gradient of L2? Well, L2's gradient isn't so simple. It's not even in the form y equals mx plus c. So the first thing we want to do is get this into the form y equals mx plus c. So we can see what the gradient is. Because remember, m is the gradient value. Now, in order to get this into the form y equals mx plus c, we're going to leave 5y on one side and take everything else over to the other side. So it's going to be a positive 10x minus 4. And then we're going to divide by 5. So 10 divided by 5x and 4 divided by 5. So 10 divided by 5, that gives us 2x, and we can leave the 4 over 5 as it is. So what's the gradient here? The gradient of L2 is also 2. So therefore, the same gradient, they both have the same gradient, and therefore they are parallel. Question 13. Enlarge the shaded shape by the scale factor minus 2 with the center of enlargement 0, 0. So we are enlarging right from there. Now, it's a negative enlargement, so be careful with that. That simply means that if you start here and you look at each corresponding point by going across and down, then you just go opposite. So because you went this way for that one, you multiply it by 2, but you go the opposite way. Because you went down to get to this point here, you multiply that by 2 and you just go up that way, okay, the opposite way. So instead of down, you go up. That's what the negative does, all right, with the scale factor. So let's start off with this point first. So this point, to get to it, we went what? From 0 to -3 here, and then we went down by 2. Okay, so that would now be, instead of going back by 3, we're going to multiply that 3 by 2. So we're going to have 3 times 2, which is 6, but we're going to go forwards by 6 right there. Okay, and this was going down by 2, so we're going to go up by 4 right there. So this is where this first point is, right here. Okay, and we can do that with all the other points as well. All right, so this one here, this point here, it's going back by 5 and down by 2. So it's going to be across by 10. 5 times 2 is 10, and up by 4 right there. Okay, it's going to end up right there. And the others, so this point here, 2 across that way and 4 down. So it's going to be 4 across and 8 up. So right there. And I'll just do the other mark in here. And then I just join these points along using my ruler. So there's my shape. Now, one thing you should notice is each of these corresponding points should go through that point. So if you were to get a ruler and mark them like this, they will all go through that center of enlargement right there. All right, question 14. Saffron wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 180 fish from the lake. She puts a tag on each of these fish and puts them back into the lake. On Saturday, Saffron catches 305 fish from the same lake. She finds that 45 of the 305 fish are tagged. Work out an estimate for the total number of fish in the lake. Right, so let's start with this sentence up there. So 180 fish are caught out of the total number of fish, which we don't know, the population of the lake. Now we're going to equate this to what happened on Saturday. So on Saturday, 305 fish were caught, and out of those, 45 were tagged. So you can see I've set up this equation right there. All right. So now all I need to do is find out what the value of n is. So to do that, I'm simply going to cross multiply. So I'm going to do 180 times by 305, and then 45 times by n, like that. And then 180 times by 305, I'm going to divide that by 45 now. So 180 times by 305 divided by 45. That isolates n, and I just need to calculate that. And n is equal to 1,220. So that's how many fish are in the lake. All right, question 15. The ratio of Martha's hourly pay to Khalid's hourly pay is 65. Both Martha and Khalid get an increase of £1.50 in their hourly pay. The ratio of Martha's hourly pay to Khalid's hourly pay after this increase is 13 to 11. Work out the hourly pay before the increase for Martha and for Khalid. So let's begin. Where do we begin? Let's write down M and K, which signifies Martha and Khalid. And we'll start off with the ratio that's given to us, which is 6 to 5. So 6 to 5. Now, because we don't know what the hourly pay is, we're going to call it 6x and 5x. Now, what happens next? This translates into their new hourly pay, where they get both of them £1.50. So it's going to be 6x plus 1.5 for M and 5x plus 1.5 for K. This new ratio after the increase is now 13 to 11. So that means that, let's just do it this way. 13 divided by 11 is equal to 6x plus 1.5 divided by 5x plus 1.5. Let's set that up. So 6x plus 1.5 divided by 5x plus 1.5 is equal to 13 over 11. Now, you may be wondering why I did all this. Well, 13 to 11 is the new ratio after their pay increase. Okay, and this is what the pay increase looks like. So that means they are equivalent and this is equivalent. So therefore, this divided by that is equal to that divided by that. Likewise, 11 divided by 13 will be equal to 5x plus 1.5 divided by 6x plus 1.5. Okay, same way. So I just need to solve this now. So in order to solve this, I'm going to cross multiply. So let's go ahead and do that. So that's going to be 11, 6x plus 1.5, 13, 5x plus 1.5. And if we expand that out, we get 11 times 6. That gives us 66x plus 16.5. And 13 times 5 here gives us 65x. And 13 times 1.5 is 19.5. If we collect all the x's on one side, so take the 65x to the other side, that would leave us with just x on this side. And then we take the 16.5 minus it from the other side. So 19.5 minus 16.5, that gives us 3. So we know now x is equal to 3. But the question asks us, work out the hourly pay before the increase for Martha and Khalid. Well, the hourly pay before the increase was this. So for Martha, it was 6x, and for Khalid, it was 5x. Now we know what x is, we can sub that in. So for Martha, for M, it's going to be 6 times 3, which is 18. So for Martha, £18 an hour. And for Khalid, it's going to be 5 times 3, which is 15. Khalid was on £15 an hour. So that's your answer. All right, question 16. This is a Venn diagram question. The manager asks 100 customers which type A, B, or C that they use. Now, before we start, with Venn diagram questions, make sure that you read through several times, more than once for sure, and you fill in the diagram slowly, okay? If you can, start with the middle, okay, right here, okay? This is how you normally start Venn diagram questions. So let's go ahead and read all this information. This is the information that we're going to use to fill in our Venn diagram. So the first one, it says 4 use all 3 types. That 4 will go right in here. Okay, so that's right there, 4. So that's done. Then it says 16 do not use any type of A, B, or C. That means 16 people are not inside these circles. Where are they? They are outside, right there. So that's that done. 8 use both A and B, but not C. So they use A and they use B, but they can't be inside this circle. Well, that just leaves us to go in here then. So that 8 goes in here. That's done. 14 use both type B and type C. So B and C. So that means 14. Now this is all B and C. So that will also represent 14. Okay, all of that. Now, since we've got 4 in here already, in here, just in here, we'll have to do 14, take away the 4. And that gives us 10. So that will be the 10 that goes in here. All right. So just to explain this again, what that means is, you know, when it says 14, use both B and C. B and C are these circles right there. And where the B and C intersect each other is right here. So all of that has to represent 14. Okay, so if you want just this one, that means B and C, they are, yes, but they don't include the A. Whereas the 4 includes A, B, and C. Next, it says 62 in total use type A. That means this entire circle here is worth 62. However, there are 2 parts of this circle missing, so we can't do anything with that 62 just yet. All right, not just yet. So let's continue reading. It says all 20 who use type C also use at least one of type A and B. Now, what does that mean? There are 20 that use type C, but they also at least use A and B. That means just in here, which is exclusively C only, nobody exists, because all of the people that use C use something else, A or B. All right, so in here, we can write a 0 in there because nobody just uses C exclusively. So that means that 20 would be represented by this, because that's still C, okay? So 10 plus 4 plus something has to equal 20. So to find out what goes in here, I want to do 20 minus 4 plus 10, which is 14. So 20 minus 14, that gives me 6. So in here is 6. So that part is done. Now, let's go back to that 62 in total that use A. Now look, all of that circle has to be equal to 62. Now I've got these 3 done. So to find out what goes just in here, I'm going to do 62 minus 8 plus 4 plus 6. And that gives me 44 in total. So 44 will go in here. So that's that done. Now, I don't have anything for just B alone. To do this, originally there are 100 customers. That means the entire Venn diagram, all of these numbers, have got to equal 100, including what goes in here. So if we were to add up all of those numbers and take them away from 100, we should be left with just what goes inside B, which is going to go here. All right. So let's go ahead and do that. So let's add up all the numbers and take away from 100. That gives us a total of 12. So 12 goes in here. And there is your Venn diagram completed. Now the question goes on to say, one of the customers is chosen at random. Given that this customer uses type A, find the probability that the customer also uses type B. Now let's just focus on this given here. If something is given to you that, look, this customer definitely uses type A, that means it's going to be out of how many is in A. And what's A out of? A was out of all of that. So it's in here, the customer's in here. And all of that is equal to 62. We also told that up here. So it's going to be out of 62 people. All right, so wherever the probability fraction is, it's going to be out of 62. And also they use B. So if they're in here and they also use B, well, that's going to be this 8 and the 4, because that's the B circle. All right, so we're going to do the 8 plus the 4 as well. And that's going to be 12 out of 62. And that's your final answer. Question 17. A solid cone is joined to a solid hemisphere to make the shape that you see below. We've been given the formulas for the volume of the sphere and the cone. The question says the diameter of the base of the cone is 7, the diameter of the hemisphere is 7, the total volume of T, which is the entire shape here, is 120 pi centimeter cubed, and the total height of T is Y. Okay, calculate the value of Y. So we want to calculate this value here. Now, this question, you need to break it up. All right, you need to break it up. So let me give you my plan, my vision for calculating this question. All right. I am going to find the total volume, but using the hemisphere on its own and the cone on its own. So I'm going to find the volume of the cone and the volume of the hemisphere separately, add them together and make it equal to this, which is the total volume of the entire thing. All right. So that's my plan, my mission. So let's start off with the hemisphere. The hemisphere is half of a sphere. Okay. So you're going to divide this by 2. So whatever this is, you're going to divide it by 2, or the same is times it by half. All right. So the volume of the hemisphere, which looks, let me draw a hemisphere. This is your hemisphere. Okay. Now, what's the radius? You need the radius for that, right? Now, the radius is going to be half of the 7. So it's going to be 3.5. Okay, that's your radius. And the height of this is also going to be 3.5. Because why? Because from the center to any part of the circle is going to be the radius. All right, so the height of this is also going to be 3.5 centimeters. So that's the first one, the hemisphere. Let's look at number 2, this the cone. All right, so with the cone, again, it's going to be 3.5 centimeters. And the height of the cone, we don't know. So we're just going to call it H. Now, Y is going to be the height of the cone plus the height of the hemisphere. So we can do a separate Y along here. This is going to be Y. So Y is going to be 3.5 plus H. All right, that's what Y is going to be. 3.5 plus H. H is the height of only the cone right here. Okay, that's H. And I've just made that up. I'll just put a H there. So let's go ahead now and calculate the volume of number 1, which is the hemisphere. So like I said before, we're going to use this, but we're going to divide it by 2 or times it by half, because it's not the full hemisphere that we want. All right. So half times 4 over 3 times by pi times by radius. What's the radius? 3.5. And we cube it. So that will give me the volume of my hemisphere. And if you calculate that on your calculator, leave it in terms of pi, you get 343 over 12 pi centimeter cubed. All right. So that's the volume of your hemisphere. Number 2, we're going to calculate the volume of our cone. So the volume of a cone is right there. So we don't need to half it or anything like that, like we did previously to the hemisphere. It's a complete cone. So it's just going to be a third times by pi times by radius, which is 3.5 squared times by h, the height. So if we simplify that, we get 49 over 12 pi times h. So this is my hemisphere, this is my cone. I'm going to add them together, remember, and I'm going to make it equal to this volume right there. Okay, why am I doing all this? You're going to see shortly. Now, I need to get some space. Right, so therefore 343 pi over 12 plus 49 over 12 pi h is equal to the total volume of T, which was 120 pi. Okay, now I can cancel out all the pi's, and I'm left with 343 over 12 plus 49 over 12h is equal to 120. Next, I can multiply by 12, and that will get rid of all the denominators of 12. So it's going to be 343 plus 49h. I'm going to need to do 120 times by 12, and that is 1,440. Now I'm going to take the 343 to the other side, so I get 49h is equal to 1,440 minus 343. So 49h is equal to 1,097. And finally, h would be equal to 1,097 divided by 49. And that is my value for h. Now, let's go back to this. Y, remember that's what we need to find anyway. Y, we need to find the value of y. Y is equal to 3.5 plus h. Well, that would be 3.5 plus 197 over 49, which is what h is. So knock that into your calculator. And that gives us a value for y, which is 25.9 to three significant figures. So 25.9 centimeters. Now the question goes on to say the diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. Assuming that the total volume of T does not change, explain the effect this would have on your answer to part A. Right, so what's going on here? Let's see. We are told that the diameter, this, is increasing. It's getting bigger, okay, by the same amount. Obviously, they're both the same diameter of each other because they're tied to each other. Now, the volume, if it doesn't change, that means as this gets bigger, this would get shorter, shrink down, because the volume needs to stay consistent. So what would happen is the height of this would go down. So the height of T would decrease. That's the only way that you can keep that volume consistency. Question 18, we've been given this diagram and we've been asked to calculate the length QS. So let's go look at where QS is. QS is right here. Let's go put an X right there to say I need to come and find what you are. Right, so how do we work on this? We've got this triangle here. I'm thinking of the cosine rule, the sine rule, and that sort of stuff. But I've only got two angles here, so that's not good to me just yet. So let's look at this triangle here. I've got two sides and an angle, no problem. And I could use this to find this length here. So once I know this length, then I can have more action on this triangle. So let's draw this triangle out separately. So this is Q, this is P, this is 27, and this is 9.4 centimeters, and that's point R. All right, so I want to find, and this is 11 as well. So I want to find RQ. So how do I find RQ? I can use a cosine rule. So now with the cosine, when it comes to cosine rule, I can make my own letters up. So I don't have to have this as A, P, Q, and R. I can have this as A. I can have this as small a. I can have this as B. I can have this as small b, etc., etc. All right, it's up to you. You can do that. But I'm going to assume that you know how to use that cosine rule quite well. So I'm just going to write RQ squared, which is this length here. So in your case, you'll have A squared, okay? And then I'm going to do 9.4 squared plus 11 squared minus 2bc. So b here would be 9.4 times the c, which is 11, and then cos 27. So go ahead and put that into your calculator. So RQ is going to be, if you put that into your calculator, you should get 25.0998508. Square root the answer. So RQ is equal to the square root of 25.0998508. And RQ is equal to 5.00997 dot dot dot. That's practically 5 centimeters. Right, so I know now this is 5 centimeters, and now this triangle will also be 5 centimeter length right there. So let's go ahead and draw that triangle. There we go. So that's 41. That's 88. That's R, Q, and S. And we know that this is 5 centimeters. All right, so what rule do I need to work out this side here? Well, this is going to be using the sine rule. Okay, we have opposite pairs right there. So sine rule. So it's going to be x over sine 88 is equal to 5 over sine 41. And we rearrange that in terms of x. So it's going to be 5 times sine 88 over sine 41. And that gives us a value of x of 7.62 to 3 significant figures. Question 19. You've been given the two functions. And for part A, you've been asked to find g of 16. What does that mean? That simply means plug in 16 for the x in the g function. So that would be cube root of 2 times 16 minus 5. And that will give us the cube root 2 times 16 is 32. 32 minus 5 is 27. So the cube root of 27 is 3. So the answer is 3. Next, find HG inverse. Now, what does this mean? Find HG inverse. That means find the inverse of G and then do the composite function thing, which is to put into H. So let's go ahead and find inverse of G first. Okay. And then we're going to sub into the function H of X. Okay. So to find G inverse, we're going to use the formula here, but instead of this, we're going to call this a y. So we're going to have y is equal to the cube root of 2x minus 5. And we're going to make x the subject. So we're going to cube both sides. So y cubed, we'll get rid of this cube root on the other side. So 2x minus 5. And we're going to take the 5 over. So y cubed plus 5. And then we're going to divide it by 2. And then x is on its own. So g of inverse is going to be x cubed plus 5 over 2. We just replace the y with the x once we write it as the inverse. Okay. So this here is the inverse of g of x. Now we're going to sub this into hx. So hx, just a reminder, is 1 over x. So it's going to be, sub this in, 1 over x. So x is going to be all of g of x, the inverse. So that is hg inverse x. Now obviously we can't leave it like this. What happens when you have a division over a division? You take the 2 and you multiply it right at the top. So that will simplify to 2 over x cubed plus 5. And that is your final answer. Okay, question 20. A, B, C, and D are points on the circumference of a circle. Center O, ADE, and BCE are straight lines. Work out the size of angle CDE. All right, so I'm just going to highlight this here, and then I'm going to go to the question. CDE. I need to find this angle right there. So let's just go ahead and mark it right now. Right there. Okay, that's what I need to find. So where do I begin? Give a reason for each stage of your working. All right. Let's look at this here, right there. Okay. We have a cyclic quadrilateral. So we know that this and this are going to be equal to 180. We can find angle BAD right there by using this, because angle at the center is twice the angle at the circumference because they come from the same arc. All right. So angle BAD is going to be half of 132, which is 66 degrees. And the reason for this is angle at center is twice angle at circumference. Okay. Angle at the center is twice the angle at the circumference. So let's go ahead and mark that in. That's 66. Now we did say that this will be equal to 180 together. So therefore, BCD is going to be 180 minus 66. And that gives us 114. And the reason for this is it's a cyclic quadrilateral. Okay. Just going to zoom out a little bit so you can see more of the diagram and give myself some room to write. So let's go ahead and write that in here. So that's 114. What's next? Well, we have a straight line right there. So therefore, these two angles here are going to equal 180 angles on a straight line. So angle DCE, this angle right here, so DCE is going to be 180 minus 114, which is 66. So that right there is 66 degrees. And the reason for that is angles on a straight line. So I've got that now. And to work out my angle, look at that, triangle. So what do the angles of a triangle add up to? 66 plus 16, take away from 180. So this would be 180 minus 66 plus 16. And that gives us 98 degrees. So this here is 98 degrees. And the reason for that is angles in a triangle add up to 180 degrees. So angle CDE is equal to 98. Question 21. The graph of y equals f of x is shown. So this is the graph. On the grid above, sketch f of minus x. What does that do? It's a reflection in the y-axis. All right. In other words, let me just zoom in here. See, it's got a negative in front of the x. If you take any x value, like the x coordinate, you can just put a negative in front of it. So here, right here. Okay, let's say the x value is 2. And you put a negative in front of that. So you have minus 2. Well, this point now would end up on the minus 2 side, which is on this side. So it ends up here. All right. This point right here, let's do a different color. This point right here, okay, is minus 3, let's say. If you put a negative in front of a minus 3, it becomes a positive 3. So this point right here would end up on the positive side right here. Okay. So what ends up happening is you have a reflection in this axis right here. So that's why it's a reflection in the y-axis. This point here is obviously going to end up here as well. And finally, this one is going to end up, is going to be 1, 2, 3, 4, 5. So it's going to be 1, 2, 3, 4, 5 on the other side, right there. Right there. So now I'm just going to sketch it. So that's how it looks. Okay, so the next part of this question, here is a sketch of the graph y equals tan x. The graph of y equals tan x is translated to give the graph of y equals gx. Following the translation, the point Q, shown on the graph above, moves to the point R. Now the point R has the coordinates 90 minus 5. Find an expression for g of x in terms of x. Right, so let's just write down what's going on here. So Q currently now is at where? Right here. So we don't know any markings yet, but if you remember, it's a tan graph. So on the tan graph, the asymptotes, which are these dots, are at 90, 270, and this is 180, and this is therefore 360. Okay. So now we know Q. Q is at 360 for the x and 0 for the y, because the y-axis right there. Q is 0. Okay. And then Q goes on to become the following coordinate, 90 and minus 5. So what we need to ask ourselves is, how did 360 become 90? Okay. So it's clearly gone backwards. So it's gone from 360 to 90. That means it's gone backwards by 270 degrees. So therefore, it's gone that way by 270 degrees. Next, how does 0 go to minus 5? So 0 went down to minus 5. So it's clearly gone down by 5. So if you remember your translations of graphs, going backwards is a matter inside of the bracket with the x. So g of x is going to be equal to an x with a plus 270. Remember, inside the bracket, if you're going negative to the negative, it's a positive inside the bracket. Okay? And the minus 5 would be outside, like that. So g of x, in fact, let me just move that along a little bit. So g of x is equal to x plus 270 in a bracket minus 5. Now, of course, this is the tan graph, so you have to write tan outside as well. But even if you didn't write tan, I'm sure the examiners will still give the mark if you show the translations. Moving on to the last and final question. Find algebraically the set of values of x for which x squared minus 49 is greater than 0 and 5x squared minus 31x minus 72 is greater than 0. We're going to have to do this separately. So let's start off with the x squared minus 49 on this side first. So we know that's greater than 0. We factorize. So it's a difference of two squares. So x 7 plus minus. Now for the sake of our working, we're going to write x is equal to minus 7 and x is equal to positive 7. We're going to draw a graph. So minus 7 is here, positive 7 is here, and we have to sketch this. Now it's a positive x squared, so we're going to have a smiley face like that. So this is what our graph will look like. Now, we want greater, the y values greater than 0. So where are the y values greater than 0? This is the y-axis. All right, this is the y-axis. So the y values greater than 0 are on those two. So it's when it's greater than 7 and less than minus 7. So x is less than minus 7 or x is greater than 7. So we'll leave that for now. Now let's focus on the second one. So 5x squared minus 31 minus 72. So we're going to factorize this. So you can use the AC method to do this. So you could do 5 times minus 72. So 5 times minus 72. Remember, it's a calculator paper as well. You can just multiply that like that. And now you work out the factor pairs of 360. So you've got 1 and 360. You've got 2 on 180, so on and so forth. And you've got 9 and 40. You can factorize this in whatever way you know. I'm just using the method that I teach in one of my videos. So you want a negative 360 when you multiply, and you want to add to give minus 31. So minus 40 and plus 9. So that's going to be 5x squared here. And here we're going to have minus 72. And then we're simply going to put these values in here, and you can switch them around. You don't have to do plus 9x first and minus 40. You can do minus 40 because minus 40 and 5 have a lot more in common, and so does 72 and 9. All right, so I'm just going to switch those pairs around. So minus 40x plus 9x. And then I'm going to factorize. So I'm going to factorize that, and I'm going to factorize that. So what's common between 5 and 40 is 5 and an x inside here. So we need an x minus 8. And then plus 9 is common to 9 and 72. What do we need here? We need an x. 9 times 8, so minus 8. And then it's going to be 5x plus 9 and x minus 8. Right, so for the sake of finding our critical values, x is equal to minus 9 over 5, and x is equal to 8. Greater than 0, so I forgot to do it here, so let's just do it here. So we're looking for greater than 0, so we're going to have to draw this graph again. So this was x is equal to, is at minus 1.8, or x is equal to 8. So minus 1.8, let's just put it here, and 8 here. Again, it's a smiley, so it's going to be a quadratic that looks like that. So we're looking for the values of y, which are greater than 0, once again here and here. So we're going to have x is less than minus 1.8, or x is greater than 8. Okay, so here and here is when this inequality is satisfied. Now we're going to have to represent both of these on a number line, and that's the last step. So here's a number line. I'm just going to make up some values. I'm just going to put down the values that we are using. So minus 7, we've got minus 1.8 somewhere here. We're going to have a 7 here, and we're going to have an 8 here, let's just say. It doesn't have to be accurate. It's just a representation to help me do this next part. So this part I'm going to do in purple, and these two I'm going to do in red, okay? So let's start off with x is less than in purple. So here's 7. It's not going to be a shaded circle because it doesn't include 7, and it's going to be going that way. X is greater than 7 is going to be going that way. Let's do the others. So x is less than minus 1.8. So let's do up here. Less than minus 1.8 is that way. And x is greater than 8 is that way. Now, what are we looking for? Why do we do this? We are looking for the parts where they are both common. So can you see here, this red one starts off on minus 1.8, and until it hits this stage, it's not the same. But after this stage, so after minus 7, it's the same. So what we're saying here is this is where the commonality begins for both of them. Okay, so that's one commonality. Let's look at the other side. On the other side, you've got x starts from 7, but it's not the same. They're not the same. They're not common. But once they hit 8, they are both the same. All right. So once they hit 8, they are both the same. They continue being greater than 8. So what we can say that satisfies both inequalities is that x is less than minus 7 or x is greater than 8. And that's your final answer. Hope you enjoyed this lesson, guys. I try to include as many details as possible so that you're not just doing these questions and learning how to answer these questions, but you're also able to apply the techniques and methods onto similar questions that you might find in your exams. Don't forget, I'll be doing a walkthrough of the predicted papers for this year, so make sure that your bell notifications are on. See you in the next video, guys. Bye for now.